Final review, Unit 5. Okay, so example 1, you have a word problem. So let's go ahead and read it. Two numbers are consecutive, positive, odd integers. So before I finish reading it, give me an example of consecutive, positive, odd integers. 1 and 3. Very good. Because they're right next to each other and they're odd. Okay. So, but if we're talking about those in terms of variables, who remembers what values we give them as variables?
X plus 1.
Good. X and x plus 2. Because what would you add to 1 in order to get to 3? You would add 2. So it's x and x plus 2. All right, so then we're going to go down here. It says the square of the larger. Well, what's bigger, x or x plus 2? So the square of a larger means you would have x plus 2 squared. Is means equals. And then it says 3 less than 12 times the smaller. Well, whenever you see less than and you already have an equal sign, that means you work backwards. So 12 times the smaller will be 12 times x. Less than means you're going to subtract, and then you have 3. And then now you're going to solve this. So in order to solve this, you have to use your box or FOIL to multiply out x plus 2 squared. Again, I can do this one in my head. If you want to use the box, you can. But I'm going to end up getting x squared, and if we go 2 plus 2, that would be 4, so plus 4x. Plus, and when you multiply 2 times 2, that would make 4. And then this equals 12x minus 3. And in order to finish solving this, we need it set equal to 0. So I'm going to subtract 12x, and I'm going to add 3 to make this set equal to 0. So we end up getting x squared minus 8x plus 7 equals 0. Now we need a factor. Okay, so what multiplies to be 7 and adds to be negative 8? Good, x minus 1, x minus 7. And when we set those equal to 0, what does x equal? 1 and 7. Now, these are giving you the first term. So we normally check. And oftentimes one of the numbers don't match. But in this case, are these both positive odd integers? Right, because they're both like the x values, not the x plus 2 values. Okay, so if x is 1, the consecutive number next to 1 is what? 3. If x is 7, the consecutive number next to 7 is 9. So you actually have two different sets of answers here. So we have 1 and 3 and also 7 and 9. And this was the annoying part back when we were doing this as well. But on this one, it says to find the sum of the two numbers. So my sums are what? 4 and 16. So those are my answers. 4 and 16. Bless you. Okay, questions on example 1? Okay, example 2. The thing that you want to remember with i's is what? Very good. I squared equals negative 1. Another thing is that you never want an I in the denominator. Okay, so we want to remember this, and then no i's in the denominator. Okay, so on example 2, all we're going to do is distribute. Good. So 7i times 2i makes, I'm going to write this first as 14i squared, okay? And then 7i times 5 will make 35i, okay? But like you already said, we know that I squared is negative 1, so we end up getting 14 times negative 1, which is what? So we get negative 14 plus 35i, and that's my answer. Also, remember that you always write it as the real part first and then the I part second. So sometimes you have to flip things around. Questions on example 2? Okay, example 3. We can't have an I in the denominator. Who remembers what we do to get rid of the I in the denominator? Conjugate. Good job. Good math words. Okay, and what is the conjugate on this problem? You guys are amazing. 4 minus I is correct. So whatever I do to the bottom, I also have to do to the top. On the bottom, you might want to go ahead and do a box just to make sure you do the math correctly, or know that this is the difference of squares. You could do it that way as well. If I go ahead and do the box, just to be safe, I have 4 and a negative I and 4 and a positive I. 4 times 4 is 16. And then 4 times negative I is negative 4I. I times 4 is 4I. And I times negative I is negative I squared. But a negative I squared is going to be a negative 1, which will make a... Does that make sense why that's positive 1? Because that's a negative times negative 1, which makes a positive 1. So I'm going to cross all that out, and you have a positive 1, a positive 16, and those also canceled out. So what is my denominator? 17. And on the top, we multiply through, and we get 3 times 4 is 12, and 3 times negative I is... And can I reduce anything there? No. That is my answer. Okay, example 4. Do you remember what we talked about with example 4? Divide by 4 and see the remainder. Okay, because if we were writing this out, remember, and you want to do the first 4. I to the first power is just going to be I. I to the second power is going to be negative 1. I to the third power is going to be what? Negative I. And I to the fourth power is going to be positive 1. Because each time you're multiplying by an additional I, which is changing these. So if we take 4 and we divide 4 into 13, how many 4s are in 13? 3, which is 12, and we subtract, there's 1 left over. So that means for I to the 13th, we're going to end up with just I to the, whatever your remainder is, I to the first. And I to the first is just I. So now we have negative 5 times I, which is negative 5I. Now, there's lots of ways of doing this. You could have written out 13 I's, and you know that every 2 I's makes a negative 1. Okay? Also, since this is an odd power, you know that you're going to end up with 1 I left over. So it's either going to be an I or it's going to end up being a negative I. Are we okay with what happened here? Yeah? Okay. You could also count. I was going to show you this too. Since there's 13 I's, if you get those 4 written, all you do is go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And it ends up here. That works as well. Okay? All right, example 5. What are we going to do? Notice that there's no plain x term, so we're not going to factor. We just want to solve for x. So in this unit, we are wanting to get x by itself. So what am I going to do, or try to get my square by itself? Good. Subtract 40 to both sides. We get 3x squared equals, and 4 minus 40 makes what? Good. Negative 36. Is my square by itself? Good. We're going to divide by 3 to both sides. X squared equals negative 12. Now, how do I get rid of a square? You take the square root of both sides. Okay? Anytime you make a square root, your answer is going to be plus or minus. Good. So we get x equals plus or minus. Now, what do we do with that negative under that square root? It comes out and becomes an I. So I have I root 12. Can 12 break down at all? Good. 4 times 3, and then 4 is, so I have a pair of 2's with a 3 left over. So my answer is x equals plus or minus 2i root 3 is correct. All right, example 6. What does it mean to find the sum? You're just going to combine your like terms. But what do we need to be careful with? So I'm just going to rewrite this and get rid of my parentheses. So I have 7 plus 2i. A plus would not change anything. So I have plus 3 minus 4i. But a negative changes these signs. So I end up with negative 4 plus 7i. Now I'm just going to combine all of my like terms. Start with your real part first. So I have a 7, a positive 3, and a negative 4. 7 plus 3 is 10. 10 minus 4 is 6. Then you do your i's. 2i and negative 4i is negative 2i. And negative 2i plus 7i makes a plus 5i. And that is your answer. Okay, moving on. Example 7. What are you going to do here? You're going to make a box and you're going to multiply it. I'm going to give you a minute to try that on your own. If you want to show me your answers, you can. Unless I'm not here to see your answers. Perfect. Good. Perfect. Good. Good. Combine like terms. Good. Okay, so if I make a box, the correct answer is 23 minus 2i. Remember, the one thing is that you want to try to write your real part first and then your imaginary part second. So we have 3 and a 2i and 5 and negative 4i. When I multiply here, 5 times 3 is 15. 5 times 2i is 10i. Negative 4i times 3 is negative 12i. And negative 4i times 2i is negative 8i squared. But I squared is really negative 1. So negative 8 times negative 1 ends up making a positive 8. So I have an 8 and a 15. That canceled out. And that adds together to make 23. And 10i and negative 12i makes a negative 2i. Okay, example 8. What number should be added to both sides to complete the square? Do you guys remember this? This is where you add the blank. So you have x squared minus 8x plus blank equals 15 plus blank. So they're wanting to know, what number are you adding? What number are you putting in those blanks that you're adding to both sides? How do we find that number? Good. You take negative 8 divided by 2, which is negative 4, and negative 4 squared is, so what number am I adding to both sides? 16 is your answer. Okay, example 9, what are you going to do? Do your box. We'll go ahead and do this together for time's sake. So I have 3 and negative 4i and 3 and negative 4i. When I multiply there, 3 times 3 is 9. 3 times negative 4i is negative 12i. 3 times negative 4i is negative 12i. And negative 4i times negative 4i makes a 16i squared, but we know I squared is actually, so we end up with a negative 16. So I have negative 16 and 9, which makes negative 7. And negative 12i and negative 12i makes negative 24i. And that is your answer. Example 10. What do I have to do?
Conjugate.
The conjugate is correct. What is the conjugate? 3 minus I is correct. So let's go ahead and do the box to be safe on the bottom. So I make my box. We have 3 and a positive I and 3 and a negative I. When I multiply, I get 9, 3i, negative 3i, and a negative I squared. But negative I squared will end up becoming a positive 1 because we have a negative 1, which actually makes a positive 1 and a positive 9. The middle cancels out. So my denominator is 10. On the top, what am I going to do? Distribute. 2i times 3 is 6i. 2i times negative I,
It's negative I squared.
negative 2i squared, right? But then that will end up making
Positive.
a positive 2. So we'll write that as 2 plus 6i all over 10. Could I reduce that?
Yeah.
So, yeah, you might want to write this, though, to make sure you reduce it right, because it has to go into both if you want to split up your fractions. So we end up with 1/5 plus 3i over 5. Or you could have had it as 1 plus 3i over 5. Okay, any questions with that last part?